There is some difference between not really between the Algebra 2 and what we're going to do today, because it's going to be pretty close. But the fact that we have to be using this older text, there is one little piece in there, at least one, where the newer text, I think they made it better. I think that what they'd had in the old place wasn't as good, and I think they made it a little better by the updated version. I mean, I'm going to be doing, and always in the past, I always taught it this way anyways. I never did what they did. But sometimes kids would get confused because then they'd look in the text and they'd try to do that other thing and it just confused things. But I'll point it out when it comes up. Okay, so arithmetic sequence. Right, an arithmetic sequence is the kind of sequence that it looks like you keep adding the same number to the previous term to get the next term. A lot of the ones we used in the last lesson were arithmetic. We just didn't call them that. The way that they say it here, the sequence is arithmetic when the differences between consecutive terms are the same. Meaning, if I subtract A2 minus A1, or A3 minus A2, or A4 minus A3, take any two consecutive terms, you always get the same number. And that number is called common difference. And the common difference is represented by the letter D. I think the main thing you need off of this slide is just, arithmetic is when the difference between consecutive terms is constant, and the difference is the common difference, lowercase letter d. So, just some examples of that. Right, in this one, if you do the subtraction, 11 minus 7, you get 4. 15 minus 11, 4. 19 minus 15, 4. Every time it's the same. And, all you can really check are the numbers that you've got in front of you. And in this case, for all the ones we could check, it was always the same number, so it's arithmetic. And the common difference is 4, whatever you got when you subtract. So this is the D. Now, they did give us a formula for the nth term in the sequence, right? And that's the A sub n. Now, looking at that formula, do you recognize where the D is? We just said that the D is 4, and there's the 4 right there. It's actually the coefficient of n. That's why every time you increment n by 1, you get another factor of 4. Right? You keep adding 4. Every time n gets bigger, you just added another 4. It's kind of like the slope of a line. Right? This one, 2, negative 3, negative 8, negative 13. Okay, now the numbers are going reversed. What does that tell you about D? It's negative. So negative 3 minus 2, negative 5. And you could do this for any two consecutive terms there. So the D is negative 5. And this is the formula for the A sub n. And again, we recognize where the negative 5 goes. It's the coefficient of n. And, you can even get it with fractions. And I would recommend, if you looked at that list of numbers and said, that's too complicated for me, then just put it in your calculator, right? You can subtract 7/4 minus 3/2, and then go math, enter, enter, and turn it back into a fraction if you want. You can just leave it as a decimal, you know, it'll be the same decimal too. But in one way or the other, you check. In this case, 5/4 minus 1 is 1/4. And you can show that all those are just 1/4 difference. Right? So that's the D. This is the A sub n. And just like on the other two, we would expect that D is the coefficient of n. Okay? 1 is in front of the n there, and it's being divided by 4. So there's your 1/4. So I think in the homework, there'll be a few where, you know, you have to recognize, is this arithmetic or not? Right. The formula that we have for the nth term of an arithmetic sequence is this one. This is the difference in the two books. If you look at your book and what it says about the formula, it does it at the top of page 630. And it has it has two equations, an equals dn plus c equals a1 minus d. Right? And it didn't get to that formula, which is the one we really should be using, until you got after example 3, and it's almost like buried there as a footnote. Now in Algebra 2, when you did this last year, that was the one that we referred to as the explicit formula for the nth term of an arithmetic sequence. So this is the explicit formula. Right? And you don't want to use the one that they have as their formula in that orange book. You know, use this one all the time. Right? And we recognize the parts of this formula, right? The an represents the nth term, right? The a1 is the first term. The n is the term in the sequence we're interested in. The d is the common difference. So based on all those things. And there is a recursive, or this, I'm noticing in this book, they're actually not saying recursive, they're saying recursion formula. Okay, the recursion formula would tell you that, right, the nth term is the nth minus 1 term plus the common difference. If you know, whatever is the term before, just add that common difference, you get the next term. You good, Julian? You good? Okay, so here's an example. Find a formula for the nth term of the arithmetic sequence if the common difference is 3 and the first term is 2. Okay, so starting point would be, write down that formula from the last slide. an equals a1 plus n minus 1 times d. Now they've given us the a1 and the d. That's what you've got to plug in for. I mean, your formula at the end is going to have n in it. I mean, we're not filling in for the n at this point. Right? We're filling in the first term is 2. That goes there. And the common difference is 3. So plug in those two numbers. an equals 2 plus n minus 1 times 3. Simplify. an equals 2 plus 3n minus 3. Combine like terms. an equals 3n minus 1. Now, you can check that a little. I mean, you could at least see, would this give me the right first term if I use this formula? I mean, a1 should be 3 times 1 minus 1. Right? That'd be 3 minus 1 is 2. So at least it's getting the first term right. Right? If it didn't get the first term right, we go back to the drawing board. good, Mitch? Okay, writing the terms. The fourth term of a sequence is 20, and the 13th term is 65. Write the first 11 terms of the sequence. Okay. So let's see. The first 11 terms. I'm gonna number this, right? I'm gonna go like this. 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, the fourth term is 20, and the 13th term is 65. Right. Write the first 11 terms of the sequence. Okay, so what number do we need to know for an arithmetic sequence? Which number do we need to know in order to go from the fourth term to the fifth term? The common difference, right? The common difference would tell us, okay, well, we don't know that exactly. But we know that in order to go from the fourth term to the 13th term, how many times are we going to add the common difference? Right? We'll add it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, right? In order to go from the fourth to the 13th. I mean, it's a subtraction, 13 minus 4, right? A4 plus 9 times D equals A13. 20 plus 9 times D equals 65. So we can solve for the D. With that equation, we solve for the D. Subtract 20. 9D equals 45. So D equals 5. Right, so the common difference is 5. That tells me if I want to go from the fourth term to the fifth term, add 5, right? 25. Right? And then for each successive term, just keep adding 5. 30, 35, 40, 45, 50, 55. Okay? It didn't ask for the 12th term, so I'm not going to write it. All right, how am I going to find the third term? Subtract 5. Right? Since we're going in reverse, subtract the common difference. 15, 10, 5. So the key part is, if you're given like 2 terms in the sequence, and one of them is not the first term, right, then you're going to have to do some kind of a, subtraction, set up an equation like that. To go from the fourth to the third term, we added the D 9 times. What if we went from the 6th term to the 12th term? How many times do we add the common difference? 6. Whatever is the difference in the ordinal number there in the n, that's how many times you add D. Okay. Find the 9th term of a sequence that begins with 2 and 9. And they're saying use the recursion formula to do this. Okay, if you say so. So it starts with, I'll do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The first 2 terms are 2 and 9. Okay, so what's the common difference? 7, right? I mean, if you just know 2 terms and you're asked, is this arithmetic, how could you tell? You only have one difference to check. But when they tell you it's arithmetic, we know that's a common difference. It's 7. Right? So D equals 7. And now, when they say use the recursion formula to do this, it just means, okay, just add 7 until you get there. Right? What would the next term be? 16, 23, 30, 37, 44, 51, 58. Now, had they not said use the recursion formula, I would have thought, okay, well, I'm going to do AN equals A1 plus N minus 1 times D, because I know what the D is and I know what the first term is. So I can plug that in. AN equals 2 plus N minus 1 times 7. And then to find that the ninth term, I'm just going to plug in A9 equals 2 plus 9 minus 1 times 7, which is 2 plus 56, 58. But I guess since they said use the recursion formula, what else could they mean? Just keep adding 7. Okay, the sum of a finite arithmetic sequence is, and this should be a pretty familiar formula. It's the same one we used in Algebra 2 last year, right? Now, for sum, it's a capital S, right? S sub n equals n over 2 times, in parentheses, a1 plus an. Now, the n represents how many terms are you adding up? Right? N is number of terms. What does the first term represent? Or sorry, what does the A1 represent? And I just answered no question. The A1 is supposed to represent the first term. And the AN is the last term. Right? This thing right here is the last term. So here's a finite sequence that you could easily, before we could even write this down, you'd probably put it in your calculator and add it up and get it. But we're going to just use the formula, just to practice using the formula, because we can see all the things that we need right there. First of all, how many terms is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is the first term? 1. What is the last term? 19. So plug all of that in, right? S10 equals 10 over 2 times 1 plus 19 plus, sorry, I shouldn't have written it like that. One plus 19. Right, so that is 5 times 20, which is 100. I mean, if you recognize the pattern here, right? If you're adding and when you're doing an arithmetic, trying to add up the terms in arithmetic sequence, if you notice what would you get if you added the first term plus the last term? 1 plus 19 would be 20. If you added the second term plus the second to the last term, 3 plus 17, 20, right? The third term plus the third to the last, 20. The fourth term times fourth to the last, 20, right? Essentially, we're going to get 20 5 times. That's what we got. Right? They have a little, I think they've got it in this book too. Maybe not. In the newer book, they've got a little graphic of a famous mathematician guy, Gauss. And Gauss they said that the teacher gave him a problem to add up all the numbers from 1 to 200, and he wasn't given a formula or anything, but he just figured it out on his own, which would be one thing. I think a lot of you would figure that out on your own too. But he was like 5, right? He was like very young age when he did that, and he kind of like instinctively saw the pattern and put them together. That's the legend, anyways. Okay, the sum of the integers from 1 to 100. I mean, these are SAT kind of questions. I mean, you get questions like this on the SAT. I mean, the first thing they expect you to understand is, what do they mean by integer? Right? If you're like looking at that, not really understanding what they mean by that, you have a hard time starting. Let's say you do understand what they mean by that. Oh, that means 1 plus 2 plus 3 all the way up to 100, right? Now, a lot of you will just like write down 1 plus 2 plus 3 all the way to 100 and start trying to add them up. I've seen it, okay? Usually on the test, like in the back side, it's like there's all, no formulas used, just like that's what I would call the brute force method, okay? And sometimes it works. As long as you don't make one mistake anywhere along the way, that can work. But remember what we mean by this. It's better if you could do it in a way where you do it smartly. In a time test, you don't want to be like spending too much time adding the numbers from 1 to 100 when in fact you've got a formula that does it pretty easily. Right? This means 1 plus 2 plus 3 plus 99 plus 100. So what is the n? How many terms is that? It's 100. What is the first term? 1. What is the last term? 100. Plug it in. Plug it in. S100 equals 100 over 2 times 1 plus 100, which is 50 times 101, which is 50. A lot easier than adding up all the numbers from 1 to 100. I mean, they'll do things like, what is the sum of the even numbers, positive even numbers from 2 to 200 minus the odd numbers, positive odd numbers, to 200. And again, I mean, you could sit there and try to do all that, but it's a lot easier if you just use formulas for it. Okay. Right. Find the 150th partial sum of this arithmetic sequence. Okay. Again, now that's something somebody, believe me, will write down 150 terms and start adding them up. But you don't want to do that, right? You want to do smart, don't work just hard, work smart, right? In this case, what pieces of information can we tell? I mean, we have the Fn equals n over 2 a1 plus an, right? We need to know the number of terms, the first term and the last term. Okay, which of those things do we know by looking at these numbers? Do we know the first term? Yes, we do. The a1 is here. Do we know the number of terms? Yeah, it's the 150th partial sum, so that's the n. Do we know the last term? No, we don't know the last term. That's a little bit of a problem, right? So before we get started, before we can use that formula, we got to figure out the last term. How are we going to figure out the 150th term of that sequence? We're going to use the explicit formula for the nth term of a sequence. Now, to use that, I need to know 3 things. I need to know the first term. We already know it. I need to know the number term I want to find. I know it. And I need to know the common difference. Can I tell the common difference? Yeah, it's 11, right? So the D is 11. So first, it's like a 2-step process. We're going to plug in what we know here. A150 is 5 plus 150 minus 1 times 11. A150 equals 5 plus 149 times 11. A150 equals, I think I got that here. That is 1644. Okay. Now, in terms of our formula here, that's a sub n, right? That's our last term of the sequence. So that's what we're going to plug in here. So now we have everything we need. S150 equals 150 divided by 2 times 5 plus 1644. S150 equals 123,675. Now, if you remember last year, you had a formula sheet for Algebra 2, and it had a bunch of these formulas at the bottom. They actually had one other on there, which is not presented in the book here, but we're going to show how you can make it pretty easily, which would make this problem much easier. And then we'll redo this problem in the easy way. And you're going to have a couple homework problems like that, so you probably want to use it. I mean, if you're good with this, and just do it. We're good to me? Okay. Come on, go. Okay. So here's our formula for the sum of finite arithmetic, the sum of a finite arithmetic sequence, right? Here's the formula for the nth term in the sequence. Let's replace in this formula, since a sub n equals this, we're going to replace a sub n there. So it looks like this. Sn equals n over 2 a1 plus n minus 1 times d. Sn equals n over 2 times a1 plus n minus 1 times d. So now we have a formula for the nth term of the sequence, which actually does not involve the last term. You don't need to know the last term. You just need to know the number of the term you're trying to find, the partial sum, the nth partial sum, the first term, and the common difference. And those we could tell right away from that formula. Right? So this might be a little easier. Maybe you'll have a hard time remembering that formula, but maybe you could remember what we did right there. Just stuff that right inside, get rid of the last term. Now it's not needed. I got it written on the next slide, so there's that formula. So now if I was going to do that same problem using that formula, right, I wouldn't take a step to find the last term because I don't need it. Now I can go S150 equals 150 over 2 times 2 times 5 plus 150 minus 1 times 11. I mean, you could put that in the calculator all in one step. Boom. And you get your answer, which is, again, 123,675. Okay, so now I'm doing 3 problems that are similar to homework problems because they didn't have examples that were exactly like it. Now, in fact, this one, you've got 1 out of this section. And the directions say, find the indicated nth partial sum. It's really like the last example, right? They're trying to say, find the sum of the first 50 terms. That's the way they're saying it. They're giving you these terms, and they're saying n equals 50. right? In the last example, they said they would have said find the 50th partial sum. But that's how it's written, so don't be confused what they're asking. They're asking for the sum, S50. Okay, well, if I want to find that, again, looking at that first 4 terms in the sequence, I know first term, common difference, the n, but I don't know the last term. So it's probably better if I use this formula, Sn equals n over 2 times 2a1 plus n minus 1 times d. So let's say using that formula, the n is 50, the a1 is -6, the n is 50 again, and the d is, what does it look like d is? Looks like it's a 4, right? D equals 4. 4. And like I said, we can just put that all in the calculator in one fell swoop, as they say. Clear. 50 over 2, I'm just going to call that 25, parentheses, 2 times -6 plus parentheses, 49. Oh, I didn't need that. I'm just going 49 times 4 in parentheses. 4,600. 4,600, sound right? So again, when you get to that, remember that formula right there. Yeah. That's, yeah, given right there. Right, and the last couple involve the summation notation. When it says find the partial sum, how many terms are we going to be adding up here? N starts at 1 and goes up to 100. How many terms? 100. You could tell that the n is going to be 100. Right? Now, how are you going to know what the first term and the last term are? I mean, how would I generate the first term? Plug in n equals 1. That would be the first term, right? So the a1, right? a1 plug in n equals 1. And in this case, you get 2. And for the an, right? Plug in n equals 100. 2 times 100 is 200. So now you have everything you need for the formula. S, I'm going to just write it again. N over 2 times A1 plus AN. S 100 equals 100 over 2 times 2 plus 200, which is 50 times 202, which is 10,150 times 202, 10,100. So that's when you get it as a summation, right? They're expecting you're going to plug in the lower limit for the first term, the upper limit for the last term, and the number of terms. Remember, in this case, the number of terms is 100, clearly, because it starts at 1 and ends at 100. Okay, the next example, it doesn't. So it gets a little bit trickier, which is why I wanted to show the way this formula actually works. Okay, in this case, right, I'm looking for the number of terms. You would say not 100, right? Because it doesn't start counting at 1. How many is it if it starts counting at 51? Okay, remember the way that you do this. Subtract 100 minus 51 plus 1. Remember when you subtract the top, the upper limit minus the lower limit, add 1. I mean, even in the one we did before, right? 100 minus 1, 99 plus 1, right? It's not enough just to subtract the top from the bottom. You always got to add 1. So in this one, it's 50. Okay, now the first term in the formula, it says A1, right? And we understand that to mean the first term. Now the first term in this sequence is not generated by plugging in n equals 1, is it? You plug in 51 to get the first term, right? So in a way, that A1 is in quotation marks. You know, it means first term, whatever it is you plug in to get the first term. So in this case, we're going to plug in n equals 51. And that's why I would call that, put the A1 kind of in quotation marks. It's the first term. In this case, 7 times 51 is 357. And the same way for the AN, right? The AN is what you get when you plug in the top number. It is not going to be a 50, you know, for the 50th term. It's not the 50. It's what you get when you plug in n equals 100. So the last term is whatever you get when you plug that in. Plug in n equals 100. And that will be 700. So now, using our formula, Sn equals n over 2 A1 plus AN, right? This is the n equals 50. The n is the number of terms, right? It's not, we're not using that number. We're using 50 because that's how many terms there are. 357 plus 700, which is 25 times 1,057. 26425. So I think you got two problems like that, where you have to like extract the information you need to feed the formula from the summation notation. Good. And that's the end.